Hey everyone, here we are. We are in your lesson number 10. All right, let's walk you on through it, try to help you out with a few of these things here. So, things we're looking after here is we're focusing on the use of our graphs. And what we want to keep in mind here is when we are graphing your ordered pairs, it's always the x coordinate first and the y coordinate second, which means on your x-axis, on your y-axis. So, this helps me because now I've got labeling here. So 5 what? Well, if I go on the x-axis, ooh, I can see it says seconds. So that means in 5 seconds, all right, the Jaguar can go. And then I don't see the labeling here, so I'm going to go back up into the chart here, and it says, oh, shows the distance. Okay, that's the feet there. So be 280. All right. So same idea that's here. In 3 seconds, make a better 3 there. All right, there we go. In 3 seconds, that Jaguar can go 174 feet. So yeah, again, x coordinates and then y coordinates, which means we can get the information off the x-axis and the y-axis. So they want to know, is the distance run by the Jaguar proportional? Okay, so if it's going to be proportional, you're going to have a constant. To find the constant, we're always going to do y divided by x. So I'm going to go on up there and I'm going to do 280 divided by 5. All right, reach for my calculator. I'm going to get myself 56. Um, then what's going to end up happening is we're going to do the 174 and divide it by a 3. And what we're going to see here is, do we end up getting the exact same constant? Drum roll, please. All right. 174 divided by 3, and we get 58. So we don't. So are they proportional? No, it's not. Now, here's the thing. You might be looking at this graph and go, whoa, 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 wait a second, Mr. Seven. You told me straight path of points, and I see a straight path of points through the origin is proportional. I did. Now, here's the thing. Graphs can be misleading. That's there. I mean, we're in the hundreds up here. There might be a little bit of a bump, but because the scale is so big, we can't see it there. So, yeah, that's why we need to dig deeper and not just rely on the visual that we see here. So when it asks me to write an equation, I can't do it. I can't do it because I don't have a constant. I can't write an equation unless we have a constant. All right, so problem 2 here says championship t-shirts sell for $22 each. What points, all right, or point must be on the graph to be proportional? Okay, so this kind of leads into what we were just talking about there. In order to be proportional, we know it has to go to the origin. So we know that the ordered pair 0, 0 must be on there. All right, has to go towards the origin. And then the other thing here is we need a constant. All right. A constant is your unit rate. And unit rate means how much for one. So how much is it for one shirt? Well, it's $22. So there we go. And again, that's because it's so those will always be ordered pairs that we end up seeing. All right. The origin, because it has to. All right. And then the unit rate, because that's your constant. So again, we're going back up and we're using those ideas. So what does the order pairs 5, 110 represent? Okay, keep things in order here. So that means it's 5 what? 5 shirts. Yeah, all right. Cost, all right, $110. All right. So again, realizing what things are standing for using your order pair. So how many t-shirts were sold if you spent $88? Okay, well, let's write our equation out there. Y equals 22x. Now, where did I get the 22 from? It's the constant, all right? So because it's the constant, I can write my equation out. We're spending a total of $88. Remember, money spent, all right, that's always going to be on the y-axis that's there. So because it's the result. We don't go into a store and be like, hey, here's $88. Now tell me what I can buy. You're going to walk in, you're going to grab the items, find out what the cost is, and then give them that your so we do again want to make sure we know how to use your equation. Even though I know a lot of you are like, come on, I can figure it out. It's 4y. Well, we got to make sure again you understand where things are being put in. So, yep, there we go. So it is your 4 shirts. All right. Let's go a little bit further here. Let's do a little bit more. Let's see what we got going on here. So the following graph represents the total cost of renting a car. All right, the cost of renting a car is a fixed amount each day, regardless of how many miles the car is driven. It does not matter how many miles you drive, you just pay an amount per day. Okay, does the order pair for common? What does it? Okay, so again, what does it? What does it? So remember, x coordinates, y coordinates, x-axis, y-axis. So 4, okay, so that's 4 days, because again, x-coordinate, x-axis, and that's your cost. 4 days cost $250. So again, I'm using the coordinates to help with the axis. What would be the cost to rent the car for 1 week? Well, remember, so 1 week, all right. Well, that's 7 days. Oh, and that is each day. So I got to use the 7 days that are there. So explain our model, your reasoning that's there. I tell you what, people, I'm always about the equations that are there. So I'm going to write my equation out. So to write my equation out, I need a constant. I can see from the graph, check it out right there, 1 comma 62.5. So I know 62.5 is the constant because that is how much for 1. And there we go. All right. We're going to rent a week. So that's 7 days. All right. Days are on my x-axis. So y equals 62.5 times the 7. I'll reach for that calculator there. 62.5 times 7. Hello, 437. Oh, that was 4,000. Wow, that's a lot of money there. $437. I know it says 0.5, but we're talking dollars and cents here. So that's why I'm 50 cents that we're looking at. So there you go. I'm going to let you take it from there regarding the describing it in the context. The one I do want to look at here, you may want to take a peek at question number 5. You've got your 11 and 2/3 here. You're going to have to work with fractions here. So when you plug in your 11 and 2/3, go fractions, which means if you've got a decimal in the problem already, hint, hint, wink, wink, you will change it to a fraction. The 2/3 is a repeating decimal that's there. So use your knowledge of fractions there to solve it. Remember to check things on the answer key as you need help with things. Last thing, for your graph, you choose the scale when it comes down to it. I don't mind providing you that information there. Let me see what I ended up using there. It looks like on the x-axis down here, I ended up counting by ones. So a 1, a 2, a 3, stuff like that. On my y-axis here, it looks like I counted by 2s. So 2, 4, 6, 8, 10. So that'll be a 20 up there. All right, a 30 up there. So again, you can certainly use that to help yourself out. If all goes well, you should have a straight path of points going through the origin. All right, people, enjoy.